Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and it's the second video I'm making for my Year 12s just on some basic skills I would like them to master from chapters 1 and 2. So here are 7 questions I think AS students at this stage of the course should have mastered and should be able to do. You may want to pause the video and try these questions yourself. In 10 seconds, I'm going to go through each one and show you clearly the perfect working for each one. So in 10 seconds, I'm going to go through these. Okay, I'll go through the questions one by one. Starting with question 1. We have a quadratic expression here. It is not an equation. It is a quadratic expression because it has no equals. So I'm just going to state that it's a quadratic expression, and I've been asked simply to factorize it. I can't solve it, I can't find x, all I could do is factorize it. So I'm going to put 2 brackets here. Now firstly, I'm going to look at the 5x squared and think to myself, what 2 things must have multiplied to give me 5x squared? Well, one must be 5x and the other must be x. Then I'm going to skip the positive 6x, and what I'm going to do is I'm going to go to the negative 8 and ask myself what could multiply to negative 8. Now before I do that, I'm just going to think what multiplies to 8. Well, clearly 1 times 8 and 2 times 4. They're the only things. Now, to get a negative sign, one of the answers must be negative, and we want them to add up to a positive number. So let's think how we could do this. Suppose we had, I don't know, positive 2 here, and we had a negative 4 here, so we want a negative 4 and a positive 2. What would we get ourselves? Well, if you multiplied this out, 5x times x would give me the 5x squared. 5x multiplied by positive 2 would be positive 10x. Negative 4 multiplied by 4 would be negative 4x. And negative 4 multiplied by positive 2 would be negative 8. And combining the middle terms, we would get the expression we've been asked to factorize. So I definitely know this is right. Question 2. We've been asked to solve the quadratic expression we've just factorized equal to 0. We can solve it equal to 0. So we always try and factorize. Because in question 1 we know it factorizes as follows, we are going to straight away write 5x, take away 4, x plus 2 must equal 0. And therefore this gives us that either 5x subtract 4 is 0, or x add 2 is 0. We solve both. I'm going to add 4 to both sides here to get 5x is equal to 4, and then I'm going to divide both sides by 5, and I'm going to get myself the x is equal to 4/5 in that case, or in this case subtract 2 off both sides, and I'm going to get myself that x is equal to negative 2. And they're my 2 solutions to that quadratic equation up here. Okay, next one. Well, the same quadratic, but we're solving this quadratic graph bigger than 0, so a quadratic inequality. Now, we already know that we can factorize this as 5x subtract 4, x add 2 is bigger than 0. Now, what we must not do not do this. This is unacceptable and you will not get the answer. If you make that bigger than 0, 5x subtract 4 bigger than 0, you make that bigger than 0, and just like here, but with an inequality instead, if you write x is bigger than 4/5 and x is bigger than negative 2, you will get no marks for that. That is not correct. What you must do, so I'm going to rub this out, you should maybe write a note to yourself of what's not correct. What you must do is sketch this graph. So we're going to sketch this graph. We know it has roots. It has a root. If it was equal to 0, it would have a root of 4/5, which is less than 1, something like that, and negative 2 all the way over here. We also know that's a U-shaped graph because, so the roots, let me just state what we know. We know the roots are equal to -2, 0, that coordinate, and 4/5, 0. If we were to draw this graph, i.e. draw the graph of y is 5x squared, add 6x, take away 8. Okay, we want to draw that graph there. So we know what the roots are. We know it's U-shaped because we have positive x squared. And we also know, we do know the y-intercept if we needed to know that. That's when x is 0. If we stick x is 0 in here, we get y is -8. So we know it goes through 0 and -8. A point somewhere down here, 0, -8. If we drew the graph, here would be the graph. Oh, the graph would be a U shape, something like this, something like that. Should be symmetrical there. And we're looking for where the graph, this graph is bigger than 0. So this graph is bigger than 0, that region and that region. Now for what x is that true? Well, it's true for any x number, because remember this is the x-axis, any x number bigger than 4/5, and it's true for any x number less than -2. And they are your answers to this type of question. You must factorize, draw the graph, highlight the region you're looking for, and state the x values for which it's true. Okay, question 4. State the coordinates of the y-intercept of this. We've already done this. At the y-intercept, we know something is true. We know x is 0. So we substitute x is 0 in here. Y equals 5 multiplied by 0 squared plus 6 multiplied by 0, take away 8. So y is -8. It asks us for coordinates, so we state that the coordinates are 0, -8. Now it says state the coordinates of the x-intercepts, and the common name for this is the roots. For the x-intercept, or the root, we know something is true, that y is 0. So we put y is 0 in here. 0 equals 5x squared, add 6x, take away 8. Oh look, we've solved this before, haven't we? We solved this in question 2, and we got the answers. Well, x is 4/5, and x is -2. So writing them as coordinates, we would say 4/5, 0, and -2, 0 are the coordinates of the roots. Okay, simplify the following. When we're asked to simplify surds, I find it easy to do the following. I think it's good to list out your square numbers. 1 multiplied by 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. That usually gets us home. Right, what we're going to do is try and break 45 up. Is there any square number that we can see divides into 45? Well, 9 does. So how we're going to write this, we're going to keep that 2 there, and we're going to write root 45 as root 9, root 5. Plus, we're going to keep that 7 there. And can we think of a square number that goes into this? Well, 4, because 4 times 5 is 20. So we're going to write this as root 4, root 5. And lastly, 5 is a prime number, so we can just write that as subtract root 5. Now we can tidy this up. Root 9 is actually 3, and 2 multiplied by 3 is 6. So we have 6 root 5s from here. Root 4 is 2. 7 times 2 is 14. So we actually have 14 root 5s from here, and we've got to take away 1 root 5. 6 add 14 is 20 root 5s. Take away 1 root 5, which would be equal to 19 root 5s. I should have written an equals here, and equals here. And lastly, let's have a go at question 7. Rationalise the denominators. Now, for this first one, I'm going to suggest you always try and do something first. Before you launch in and multiply both sides by root 27, you're going to get a massive number here. Simplify both the surds on top and bottom if you can. So let's have a go. 3. Does any square number go into this? Well, certainly 25 does. So we can write that as root 25 multiplied by, I think that's going to be root 7. Because 7 multiplied by 25 is equal to that. All divided by, and keep our 2 here, 2. Any square goes into that? Well, root 9, root 3 does. Root 9 multiplied by root 3 is root 27. So root 25 is 5. 3 multiplied by 5 is 15. So we've got 15 root 7 divided by, well, root 9 is 3. 2 multiplied by 3 is 6. So we've got 6 root 3 on the bottom. Now, we can do a bit of simplifying here. We can multiply top and bottom by root 3 here because we do not want the surd there. So we're going to multiply by root 3 and we're going to multiply by root 3. On the top, root 7 multiplied by root 3 is root 21. So we have 15 root 21 divided by root 3 multiplied by root 3 is 3. 6 multiplied by 3 is 18. And we're nearly there. We can simplify the 15 divided by 18. We know that 3 divides into 15 and 18, so we could divide top and bottom by 3, and we get ourselves the answer. I'm just going to shift this down here. We get ourselves the answer dividing by 3, we would get 5 root 21 over 6, and we're done. Okay, and the last one, I'll move on to a new page to do the last one. We want to simplify this surd here, or rationalise it. Now, in this case, we can't simplify any of the surds, and they are a surd plus a number. So we're going to have to multiply the top and bottom by what it would take to, using a difference of 2 squares on the bottom to get rid of the surd. So we're going to multiply top and bottom by 2 root 3 plus 4. And we're going to multiply the top, I'm going to put brackets around the top, by 2 root 3 plus 4. Because we're using the result that a squared take away b squared is a plus b, a subtract b, the difference of 2 squares. Now, I've got a difference of 2 squares on the bottom. 2 root 3 take away 4, multiplied by 2 root 3 plus 4. So what am I going to get on the bottom? I'm going to get 2 root 3 all squared, so 2 root 3 squared, and I'm going to get take away 4 squared on the bottom. And I know that's going to be a number. That's why I chose this to multiply to remove this. But then I've got to multiply out these brackets, which I'm going to do on a separate line of working, not all in one move, in case I make a mistake. Now the bottom, 2 root 3 multiplied by 2 root 3. If you're not sure what 2 root 3 squared is, 2 root 3 multiplied by 2 root 3. Well, 2 multiplied by 2 is 4. Root 3 multiplied by root 3 is 3. So 4 multiplied by 3 is 12. So on the bottom, what we would have got is we would have got 12 take away 4 squared, which is equal to 16. Okay? Now on the top, let's multiply this out. Root 3 multiplied by 2 root 3 will be 2 multiplied by 3, because root 3 times root 3 is 3. Root 3 multiplied by 4 is plus 4 root 3. Negative 5 multiplied by 2 root 3 will be negative 10 root 3. And negative 5 multiplied by positive 4 will be negative 20. Okay, let's keep going here. 2 multiplied by 3 is 6. 6 take away 20 is negative 14. 4 root 3 take away 10 root 3 is subtract 6 root 3. And all of this is over negative 4. Now, there's a factor on top and bottom. We can divide everything through by 2. And in particular, we can divide everything by negative 2 to get rid of those negative. So we get 7 plus 3 root 3, all divided by 2. And that's my final answer for this. So that is my final answer. Hope that helped in some of your basic skills for Core 1 and Core 2. Thanks for watching.